This is my intermediate algebra course. Today we're going to continue to graph quadratic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now we learned the three forms of a quadratic expression in the previous class, and we learned how to graph using those three forms. And we also learned these three principles that help us to graph using those three forms. So you probably want to take a screenshot of all this information because we're going to refer back to this constantly in this class today. So please take that screenshot because I don't want to come back to this. Or if you have your phone, that's really that's better to take a picture with your phone so you can have that in front of you rather than having to flip back page to page. So today we're going to really do the same thing we did in the previous class, but the difference is the numbers are going to be more difficult because we're going to have to use fractions, and also we're going to have some different forms of these expressions that are just kind of variations that I want you to be familiar with. And but first we're going to do fractions, and you're probably thinking, well, why do we have to do problems that involve fractions? And well, fractions are just a huge part of the math curriculum. You can't get around them. I can't protect you from fractions for the entire duration of the course, and I don't want you to be taking a placement exam or whatever exam you may have to take, and you'll get to the point where you just freeze because you'll see that there are fractions involved, and I don't want you to be intimidated by fractions. So fractions are just a huge part of the math curriculum, and you need to get to the point where you're not afraid to do calculations involving fractions or decimals. We're going to label the constants because this is standard form, and as usual, the first step is going to be to find the vertex, and to do that we're going to first find the x value of the vertex, and we're going to use that formula, and we're going to plug in b, which is 7, and a, which is 2, and that expression simplifies to negative 7 over 4. So this is what I mean when I say we're going to have to work with fractions. You can't avoid it. They're a part of the math curriculum. And it's going to be useful for us to actually change this to a mixed number so it's easier to graph. So I'm going to go ahead and do that. Now, this is something else that we don't really do a lot because I want to try to make the numbers easy for you. But if you need some review with that, you can go back to my arithmetic course and look under mixed numbers. That's changing an improper fraction to a mixed number. And as usual, we're going to find the y value of the vertex by plugging in, and it's easier to use improper fractions when you do calculations because a mixed number is actually a sum, and sums are more difficult to deal with. So we're plugging in negative 7/4, and you're going to find as we go through this class today that I'm going to do the calculations more quickly. Because we can't show every single step of the arithmetic at this point. It just becomes too long and too tedious, and you're expected to know the arithmetic. That's why arithmetic, pre-algebra, beginning algebra, and geometry are prerequisites for this course. You're just expected to know that material. So we need to square. We need to use PEMDAS first of all. That's order of operations. We're going to do exponents first. And so we're going to square negative 7/4, and when you do that, you're just multiplying negative 7/4 times itself, and when you multiply fractions, you just multiply straight across. 7 times 7 is 49, and 4 times 4 is 16. And of course, a negative times a negative is a positive. So we get 49 over 16, and here you're multiplying a whole number by a fraction, and when you multiply a whole number by a fraction, you can just consider the whole number to be over 1. And then you just multiply straight across. 7 times 7 is 49, and 4 times 1 is 4, and a positive times a negative is a negative. So again, as we go along here, we're going to do these types of basic arithmetic operations more quickly because it just becomes too tedious to show every single step. And so here's a perfect example of that. We're going to use canceling. That becomes 1, and that becomes 8. Again, you can look that over in my arithmetic course, and we get 49 over 8. That's just a faster way. We could put 2 over 1, multiply straight across, and get 98 over 16, but that would just reduce to 49 over 8. So we need to start picking up speed here when it comes to these basic equations, or else they're just, like I said, they're just going to take too long and they're going to be too tedious. So now we have to combine these fractions, and we have to multiply both sides of this fraction by 2. And then we get 98 over 8, because we need a common denominator in order to combine fractions. If you're adding or subtracting the fractions, that is. If you're multiplying or dividing, you don't need a common denominator. So the y value of the vertex, 49 minus 98, is negative 49. And 8 goes into 49 6 times. And so now, again, if you want practice with that, you can go to my arithmetic course. So finally, the y value of the vertex is going to be, you can just, now it's important to understand that both the 6 and the 1/8 are negative. So you can just add the 6 and the 15 to get negative 21, and the 1/8 just goes along with it there. So now we have the coordinates of the vertex, the coordinates of the vertex. So we're going to go over to the left, negative 1 3/4, and then we're going to go down all the way to 21 1/8. So that's going to be about here, somewhere about there. And so now, obviously we need to find some other points, and it's going to be easiest, and this is going to be step 2. It's going to be easiest probably to just plug in 0 for x. And if we plug in 0, you're going to find that obviously the corresponding y value is just going to be negative 15. But let's just show that real quick here. So y is equal to 2 times 0 squared plus 7 times 0 minus 15. And I don't really need to do the math here. You can see that's all this stuff is just going to go away, and you end up with negative 15. So 0 and negative 15. We're going to plot that, and that's going to be about here. I'm going to go ahead and mark that 0 and negative 15. Now at this point, you might think, well, we can use symmetry, right? And yeah, we can use symmetry, but it's not as easy as you might think to actually figure out how far to go out here, because we're dealing with, and let me go ahead and write this this point down. We're dealing with negative 1 3/4, and you know that those numbers are not quite as easy as the numbers that we learned or that we used in the previous class. So using symmetry is not going to be as easy. So what I'm going to do is I'm just going to plug in negative 3 to get the next point. So if x equals negative 3, y is equal to 2 times negative 3 squared plus 7 times negative 3 minus 15. And just doing all the math on that, you don't have to show the steps for the math here. 18 minus 21 is negative 3. Negative 3 minus 15 is negative 18. So now we have the point negative 3, negative 18. And that's going to be about here. And so I'm going to go ahead and label that negative 3, negative 18. And so we can just connect the dots. And, you know, we should probably graph more points just to make sure that our parabola is accurate, but I'm not going to make you do that because it's already enough work, you know, graphing 3 points. So there you go. Again, the only difference with that problem is that, you know, the numbers were more difficult to deal with. And you need to get used to dealing with, you know, more difficult numbers, because I don't want you to freeze if you have to encounter that situation. And notice that I'm not writing a table at this point. You know, in the previous class we wrote a table, and I just did that to keep track of the points, but you know, you don't really need to do that, and we need to kind of pick up the pace when it comes to this stuff. Okay, so on to the next problem here. We're going to try one more of these before you try one on your own. Again, we have standard form, And we're going to label the constants. And so, as usual, first step is we're going to find the vertex, and to do that, we're going to first find the x value of the vertex, and we're going to use that special formula. And b is -2, and a is -1/3. But you can see right off the bat that we're dealing with more difficult numbers here. Now these 2's just cancel out. Again, it's important to understand, I'm going to start using shortcuts here. We have to start using shortcuts. And it may be more easy for you to multiply these first and then go through that whole thing. But if I see shortcuts, I'm just going to start using them. And you should have the confidence to try to figure out these shortcuts on your own. We also have a double negative, so that's going to become a positive. So we have 1 over -1/3. And so now what do we do with this? Well, that's a complex fraction. There's a lot of ways to deal with that. The way we learned how to do this in my beginning algebra course is we take, this is division, so we take the numerator and then divide by the denominator. And so when you're dividing fractions, you do two things. You change the division sign to multiplication, which means we can kind of just, I guess we can just use a dot. And you flip the divisor, so it's 1 over 3, it becomes -3 over 1, and ultimately the answer is going to be -3. 1 times -3 over 1 is -3. Again, there's a lot of different ways to show all that math, but we need to start getting to faster ways to do it, or else these problems are just going to take too long. If you have to review any of this stuff, then you need to go back to my arithmetic course, and that's okay. If this stuff is, if you're a little rusty, that's okay, but if you've never seen this stuff, that's really not okay. That means you probably are in the wrong course. Again, arithmetic, pre-algebra, beginning algebra, and geometry are prerequisites for this course. So now we're going to plug in -3 to find the corresponding x value of the vertex, or excuse me, the y value of the vertex. And so let's do the math on that. Square, we get 9. Multiply, we get 6. And -1/3 times 9, that's just going to be -3. And finally we get the y value of the vertex is 0. Alright, so we can plot that point, -3, 0. That's going to be here. And our graph's going to be going downward, so I can plot up here without having to worry about our coordinates running into the graph. Okay, so now we need some point, and I think I'm going to choose 0. I'm going to plug in 0. It's going to work in this case. So step 2, we're going to let x equal 0. And then y is equal to -1/3 0 squared minus 2 times 0 minus 3. And as you can see, it's just going to equal -3. So 0, -3, that's going to be here. And in this case, it's actually going to be pretty easy to use symmetry, because we can just count we can count 3 and then 3 over here. In the previous problem, it was not easy to use symmetry. That's going to be about here. So we have 0, -3, and at this point we have -6, -3. And connect the dots, and we're done. And again, we can make the graph more accurate by making more points, but it's just, it's not really necessary. I don't require you to be that precise. Okay, so again, you don't have to keep your work in a table. So now I want you to try number 3. And again, the whole difference here is that we're dealing with more difficult numbers. You see all the math that we had to do here? That's the difference between the previous class. And again, I know what you're thinking. You're thinking, I don't want to deal with fractions. Well, that's it's just something that you're going to have to work with in the math curriculum. You cannot avoid them. So I can't shield you from fractions and difficult arithmetic forever. You should know the arithmetic because you took my arithmetic course. So again, you should have a screenshot of all this information here. We're going to use this principle here as we do these problems because you can see it's in standard form. Now, if you get stuck with the arithmetic, again, you can just go to my arithmetic course and review how to do that stuff. So go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. Let's label constants. As usual, we're going to find the x value of the vertex by using this formula. So b is 12 and a is -5. And immediately you can see that the numbers are going to get pretty weird. So that's a double negative, so it becomes positive, and 12 divided by 2 is 6. So just, jumping ahead there, we get 6 over 5, and for graphing purposes, I'm going to change that to 1 1/5. So we found the x value of the vertex. Now we need to find the y value of the vertex, and of course we're going to plug it into that equation up there. So we have -5 and 6 over 5 squared plus 12 times 6 over 5 minus 4. And we just do the math on that. 6/5 squared is 36 over 25. And 12 times 6 is 72. And, the 5 becomes a 1 and the 25 becomes a 5. Why do I know that? Well, again, that's just canceling out. That's just a faster way to do things. You can multiply -5 straight across, but you're just going to have to reduce anyway. So we get -36 over 5 plus 72 over 5 minus 4. Again, you're going to learn these faster methods as you go into upper mathematics. Okay, so let's see here. -36, we have a common denominator already, so -36 plus 72, that's just going to be positive 36. And because we're going to graph, we want to probably use mixed numbers anyway, so I'm going to go ahead and change this to a mixed number. 5 times 7 goes in, and there's a remainder of 1. And so then 7 minus 4 is 3, so we end up with 3 and 1/5. So that is the vertex, 1 1/5 and 3 1/5. So I'm going to go out 1 1/5, which would be about here, and then up 1, 2, 3 1/5, which would be about there. So 1 1/5 and 3 1/5. And now let's see, what point should we use? I'm just going to use the y-intercept. So that means I'm going to let x equal 0. And I'm not going to do the math because you can see it's going to be -4. It's pretty obvious. When you plug in 0 there, all those first terms go away. This is the first and the second term. So now we have 0, -4. 1, 2, 3, 4. That's about here. Now, again, it's hard to use symmetry on this problem. So instead of using symmetry, I'm just going to plug in, say, maybe 2 or maybe 3. Probably 2 is better in this case. So I'm going to just plug in 2. So if x is equal to 2, then y is equal to -5 times 2 squared plus 12 times 2 minus 4. And if we do all the math on that, we get -20 plus 24 is 4 minus 4 is 0. So we have 2, 0, which would be about here. And this point was 0, -4. So again, we're not using symmetry here because those two other points, they have different y values. So this is a pretty steep parabola. And there you go. So if you got something like that, good job. Okay, on to the next problem. Go ahead and try number 4. And when you come back, we'll do it together. All right, we're back. So again, this is a standard form, so let's label constants. And step 1, as usual, is to find the x value of the vertex, which is, we're going to use this formula. And b is 9/2, and a is 1. And so we just have to do the math on that and simplify. And we get negative 9/2 over 2, because 2 times 1 is 2. And at this point, we just have, a complex fraction. There's a lot of different ways to deal with this, but the way that I taught you is to consider this to be a division symbol, and then we just, flip the divisor, so and change the multiplication. So this 2 over 1 becomes 1 over 2. Again, a whole number can be considered to be written over 1. So we just flip it and it becomes 1 over 2. Multiply straight across, and we get negative 9/4. And for graphing purposes, we can change that to negative 2 and 1/4. And now we're ready to find the y value of the vertex. So we just plug that x value into the formula as usual. And it's easier to use the improper fraction form. And we have 9/2 times negative 9/4 plus 5. And negative 9/4 squared is 81 over 16. And 9 times 9 is 81. 2 times 4 is 8. Positive times a negative is a negative. So now we need a common denominator here, so I'm going to multiply both sides of this fraction by 2, and we get kind of a big number there. Sorry I gave you such a big number. We get 162 over 16. And 81, now we have a common denominator, so 81 minus 162 is negative 81. And I'm going to change 81 over 16. So 16, that goes in, I think, 5 times. 5 times 16 is 80, so there's a remainder of 1. And then we have plus 5, and then finally, these are both negative, the fraction and the whole number. This just cancels out the whole number, so you're left with negative 1/16. A lot of students would make the mistake of saying that this is positive 1/16. It's not. It's negative 1/16, because again, this 1/16 goes along with this negative whole number, so that both the 5 and the 1/16 are negative. So our vertex is negative 2 1/4 and negative 1/16. So negative 2 1/4 be about here, and then negative 1/16 is really, really close to the x-axis. And I know that this parabola is going up because the coefficient of x squared is positive. So I can just write put the coordinates below. So we have negative 2 1/4 and negative 1/16. And so now I can probably just use the y-intercept for the next point. So that means I let x equal 0, and y must be equal to 5, obviously. We can see. I don't have to show that. 1, 2, 3, 4, 5. And again, if you plug in 0, all these terms just go away. You end up with 5. I don't need to show that. That's pretty easy. Step 3. Let me section this off. Now, we can use symmetry, like I said before, in some of these problems, but it's not easy to use symmetry here because you'd have to go out -2 1/4 over here, and that would give you a fraction. And if you plug in a fraction here, you're going to have to do more difficult math. So you have to choose your numbers wisely. I'm going to choose either -3 or -4. I think -4 is going to be easier to use. So let's let x equal -4, and y is going to be -4 squared plus 9/2 times -4 plus 5. So y is equal to 16, and then we have -18 plus 5. And so y is equal to 3. So -4 and 3. 1, 2, 3, 4, and up 3, 1, 2, 3. And again, I know what you're thinking. You're thinking, I don't like this. I don't like using all these fractions. I don't like having to do all these operations with fractions. It's tedious. And I have to remember all the stuff that I learned in arithmetic. Well, that's just the way math works. You got to use that stuff. I'm rewriting this because I keep making these parabolas a little too pointed. They almost look like V's. That was a pretty crappy parabola. So I'm going to just redraw that whole thing. Sorry about that. It doesn't have to be perfect, but it does have to look generally like a parabola. This is probably still too pointed, but you get the idea. Okay, so this other point was 0, 1, 2, 3, 4, 0, 5. Okay, so if you got something like that, good job. Okay, on to the next problem here. Now we have intercept form. The only difference is we have a fraction we have to deal with. Again, that's the point of these problems, is to get used to using fractions. So the first thing we're going to do is we're going to label everything. And again, if you haven't taken a screenshot, we have intercept form up in the middle, and then this information tells us how to deal with vertex form. And we can label the constants first just to give you an idea of what we're doing here. Remember, these signs are opposite for m and n. And the first step is to find the intercepts, the x-intercepts that is. And that's pretty easy because it's in intercept form, so we can just see the intercepts immediately just by looking at that expression. And step 2 is to find the vertex, and we can see what the vertex is going to be. It's just going to be -3. It's just between these two. But I just want you to see the formula that you can use, because sometimes it's not always easy to find the midpoint. So -4 plus -2 divided by 2. So the x value of the vertex is -6 over 2, which is obviously -3. So we found the x value of the vertex. Now we just need to find the y value of the vertex. As usual, we just plug it back in, so we get -3 plus 4 times -3 plus 2. And doing the math on that, we get 2/3 times 1 times -1, and that gives us -2/3. Again, I'm not showing every step on this because you need to get to the point where you can do the arithmetic quickly, or else it just takes too long. So now we have the vertex is -3 and -2/3. So -3, 1, 2, 3, and -2/3, which should be about there. And the parabola goes up, so I can label down here without worrying about running into the graph. we can use the intercepts because, again, this is an intercept form. So we know -2 is a point and -4 is a point. So that point was -2, 0, and we have -4, 0. And we can just connect the dots. And if your parabola looks generally like that, then that's what we're looking for. It doesn't have to be perfect, but it does have to look like a parabola. Okay, so again, that was dealing with intercept form. So let's do another one of those problems. Actually, we don't really need to do another one together. You can take a screenshot of that, and you can attempt the next problem. As you can see, that problem was a lot easier than the previous problems that we did. So go ahead and try number 6. And again, the only difference between the problems that we did in the previous class is we have a fraction that we have to deal with. So try number 6, and when you come back, we'll do it together. All right, we're back. So let's label constants first. And remember, it's opposite signs. And step number 1 is we're going to find the x-intercepts, which you can see we already found, basically. And step number 2 is we have to find the x value of the vertex. And just to show you the formula, I'm going to rewrite that formula. And we're going to plug in those numbers. And so the x value of the vertex is equal to -4 over 2, which is equal to -2. So now, as usual, we just plug that back in to find the y value of the vertex. So we have -4/5 times -2 minus 1 times -2 plus 5. And we have -3 times 3. And -4/5 times -9, so on and so forth. And that would be positive 36 over 5. Again, if you're having trouble with the arithmetic, you can just go back to my arithmetic course and review that stuff. So now, for graphing purposes, we're going to change this to a mixed number. 5 goes into 36 7 times with 1 left over, so you have 7 1/5. So -2 and 7 1/5. -2 and 7 1/5. Sorry, this program jumps around for no reason. -2 and 1, 2, 3, 4, 5, 6, 7 and 1/5. So that's about there. And I know this parabola is going to be going down, so I should write my point up here. All right, and what other point should we use here? I think 0 is going to be a good point to use. There's a lot of different, well, actually, no, I'm sorry. We can just use the intercepts. So 1 is here, and -5, 1, 2, 3, 4, 5 is here. So that's -5, 0, and 1, 0. And we connect the dots. And again, my parabolas, they look too pointed at the end. They're supposed to be rounded there. Sorry about that. It should look something like that. So if you got a parabola that looks like that, good job. Again, that was intercept form. We had to deal with fractions. Now, as you can imagine, we're going to vertex form. Now we have fractions with vertex form. So let's label the constants as usual. And remember, that sign changes, but k, the sign of k does not change. This is -1, it stays -1. This is +3, it changes to -3. You have to remember that. And again, I'm going to give you another opportunity here to take a screenshot of the information we're about to use. So the first step is to find the vertex, but because it's in vertex form, we've already done that. It's -3, -1. So that's a big step forward right there. Step 2 is we just have to find another point we can use to graph. So first I'm going to graph the vertex 1, 2, 3, 1. And I know that the parabola is going down, so I can label my point up here. And I'm going to try, I want to try a value that's going to be easy to graph. I think -1 is going to be a good x value to choose. If you think about, the operations here, you can choose a value that's going to be easier to calculate. So now y, as usual, we're going to find the corresponding y value by using that equation. And we have -1 plus 3 squared minus 1. -1/2 times 2 squared, so on and so forth. You don't have to show all the steps here, and I'm probably not going to show all the steps because, again, this is stuff that you should know by now. And then we get -2 minus 1 is -3. So -1 and -3. That'll be about here. Now, we can use symmetry. It's not going to be too difficult to use symmetry. So the distance between the points, the horizontal distance is 2. So if I go out 2 this way, our point's going to be right there, and that's going to be, well, first let me label this point. That's -1, -3. And this point over here is going to be -5, -3. So that was just an example where we had fractions in vertex form. Okay, so now I want you to try one of those problems. You can take a screenshot of this if you need to. So go ahead and try number 8. Remember, you want to label those constants, and when you come back, we'll do it together. All right, we're back. So A is equal to 2/5, H is equal to 3, and K is equal to 4. So this sign changed, but this sign did not change. That's the way vertex form works when you're looking for the vertex. Step 1 is to find the vertex, and we pretty much already did that. Step 2 is to find another point around the vertex. But let's first graph the vertex. 1, 2, 3, 1, 2, 3, 4. That's going to be up here. And the parabola is going up, so I'm going to label down here. And let's see here. We can probably choose x equals 2. We want to keep it pretty close to that vertex x value because the parabola is going to be going out of the window pretty quickly. So y is equal to 2/5 times 2 minus 3 squared plus 4. And just doing the math on that using PEMDAS, parentheses first, then exponents. -1 squared is just +1, so on and so forth. And 2/5, well, we can just write that as 4 and 2/5. 2/5 times 1 is just 2/5. 2/5 plus 4 is 4 and 2/5. So x equals 2 and y equals 4 and 2/5. So I'm going to go out 2, 1, 2, and then 1, 2, 3, 4. 4 and 2/5 is about there, and we can use symmetry. So I'm going to label that 2 and 4 and 2/5. And this point is going to be 4 and 4 and 2/5. And then we just connect the dots. So you may notice that these parabolas are a lot wider, and that's because we're using the fractions. If you have a fraction coefficient here, the parabolas look much wider. Okay, so if you got that answer, good job. Okay, on to number 9. So the previous problems, again, were just, using fractions where the numbers were a lot more difficult, but now we're going to do variations of the quadratic expression. So this, for example, doesn't look very familiar. but it's just a variation of what we did in the previous class. Now, there's a lot of different ways that we can interpret this expression to figure out how to graph it. You know, one way we can interpret it is by considering a to be 3 in standard form, b 0, and c equal to 0. So what I mean by that is we have y is equal to 3x squared plus 0x plus 0. Again, b is just 0 and c is 0, and that's why those terms are not present there. So that's one way that we can consider it with the standard form. But we can also consider this to be a vertex form, because we can say y is equal to 3 times x minus 0 squared plus 0. And you might be thinking, well, how in the world did I do that? Well, isn't it true that x minus 0 is equal to x? So I can replace x with x minus 0, right? It's very simple. And over here, I can add 0 because that's the same as adding nothing, and there's nothing there. But the reason I did this is because now it's in vertex form, you see. I can see the vertex is 0, 0 immediately. That's another way to do this problem. A third way to do this problem is to consider this to be intercept form. Isn't it true that I can just take x squared and factor it so it's x times x? And then I can change that to, I can change each x to x minus 0. X is the same thing. As we explained up here, x is the same thing as x minus 0. So I can just replace each one of those with x minus 0. And now it's in intercept form. So we can do it either, any one of these ways. We can interpret it how we want to interpret it. So if we bring that up, again, we have 3 forms that we're interpreting. We're using to interpret this expression. So which one do we want? That's the big question. Well, you can use any one you want. You can use negative b over 2a to find the x value of the vertex here. You can just use this form to find the vertex just by looking at it, or you can use this form and m plus n over 2 to find the x value of the vertex. You can do whatever form you want, but I'm going to use the middle form. And the reason I'm going to use that form is because we can see the vertex immediately. The vertex is just going to be 0, 0. So we have our vertex. And now step 2, we just need to find another point, and I think I'm going to use x equals 1, and then y must equal 3 times 1 squared, which is just equal to 3. So we have the point 0, 0, and we have the point 1, 3, and we can use symmetry, and we just have to connect the dots. All right, so that was pretty easy. Okay, let's try number 10. This is another example where we have that weird case where b is 0 and c is 0. So those other terms, again, if you were to write this in standard form, it would look like this. b is 0 and c is 0, which means that they just disappear. Okay, so that's one way to do it, but we're not going to do it that way. We're just going to interpret this as a vertex form. I'm going to put that 1/2 in front. And I just want you to be aware, I've talked about this in previous classes or courses. You can just write that negative 1/2 right in front there. Okay, there's a lot of different ways to show that. And I'm going to write this as vertex form. So I'm going to replace the x with x minus 0, and I'm going to just write a 0 out there. So now we know that the vertex is 0, 0 again. That's what's unique about these problems. And now we just need a couple more points, so I'm going to try plugging in. I'm going to try plugging in 2. It depends on what values you use. I'm going to try to use the easiest values to compute. So we plug in 2, then we have negative 2 squared over 2. And that ends up being negative 2. So 2, negative 2, and 0, 0. using symmetry. We have the following points, and we could just connect the dots, and we're done. Now again, we could have a more accurate graph if we plot more points, but I'm not going to require you to do that. So those were just examples where, again, B and C are 0 in standard form. The second and the third term are just gone. So I'm going to leave those problems, or I'm going to leave number 10 in the window. And again, you want to write it in vertex form, probably. That's the easiest way to do it. So you can see what the vertex is, and when you come back, we'll do it together. All right, we're back. So I'm going to write this in vertex form. So step 1 is to find the vertex, and obviously we have the vertex. That was pretty easy. Now I'm going to let x equal 1. Actually, I think I'm going to let x equal 2. You might use different points. That's okay. If x is 2, then y is equal to negative 2 squared. You don't really have to have parentheses in that example, but I'm just using parentheses to show you I plugged that in. So now we have 2, negative 4. That'll be about here. And we have 0, 0, and we can use symmetry. And we connect the dots. And there you go. So if you got a parabola that looks like that, good job. Okay, so now number 12. I'm going to leave number 9 in the window for you there. So try number 12. And when you come back, we'll do it together. All right, we're back. So again, I'm just going to consider this to be vertex form. And with vertex form, we can see that the vertex is 0, 0. That's what's unique about these problems. Then I'm going to let x equal, I'm going to try 2. Now we're going to plug in that x value to the equation. So y is equal to 6. So we have 2, 6. And of course we have 0, 0, and we can use symmetry. And this would be negative 2, 6. And there you go. So if you got something like that, good job. All right, on to number 13. Now number 13 is just another special case, and if you interpret this as standard form, then you have y is equal to x squared minus 4x plus 0 for c. C would be 0. So the only difference is that the c value is 0. So that's one way we can do it, is interpret it as standard form. I guess I'll just leave that. But another way we can do it, which is actually easier, is we can interpret this as intercept form. We actually cannot use vertex form very easily with this, unless we do some more math. Now, to use vertex form, we're going to have to factor out an x, and this is where students get really nervous. Okay, I factored out the greatest common factor here. And a lot of students, they don't like that. They don't like seeing that, but that's something we learned to do in my beginning algebra course. And you can go to factoring. I think it's the first class in my beginning algebra course on factoring. There's many parts. There's factoring part 1, 2, 3, and 4. And maybe a fifth class, I don't remember. But we just factored out the greatest common monomial. So there's an x here and an x here. We just factored it out. And to understand why that works, if you just distribute, if you use the distribution rule, and you go backwards, x times x is x squared, and x times negative 4 is negative 4x. So we could spend a lot of time reviewing that, but we just don't have time to do that. You can go to my beginning algebra course if you need some review on that. And the reason we did that is because now we can change it to intercept form. Again, x is the same thing as x minus 0. We learned that in the previous problems. X is the same thing as x minus 0, and I'm going to leave that color there just so you understand that completely. So we could use standard form and the rules that apply there, or we could use intercept form. So which one do we want to use? Well, actually, intercept form is going to be easier. So actually, I'm going to keep that. So I'm going to bring this up. So we factored out an x and changed x to x minus 0, and now we have intercept form, and a is equal to 1, and m is equal to 0, and n is equal to 4. Remember, the signs change. So now step 1 is to find the intercepts, and we already have the intercepts. Because we're in intercept form, we can just look at it and see them. And now we just have to find the x value of the vertex, and we don't really have to use this formula, but I'm going to go ahead and use it just so you know how it's applied. So we have 0 plus 4 over 2, and we have 4 over 2, which is 2. Again, you don't have to show these steps. You don't even have to use that formula if you don't want, because you can see the midpoint between 0 and 4 is obviously 2. Okay, so now we need to find the y value of the vertex. As usual, we bring down that equation, and actually this would probably be an easier equation to use, that second step up there. So now we're going to plug in 2, and just to be sure you understand where that 2 is coming from, I'll put it there. And doing the math on that, parentheses first, then multiply by 2, we get negative 4. So we have 2, negative 4 is the vertex. So that's about here. And the parabola is going up. So now I can use the intercepts, which we know are 0 and 4. So that's 4, 0, and this is 0, 0, and connect the dots. And there you go. So that was just another special case, another variation of the problems that we did in the previous class. The only difference is 0 was in place of c here. We had no c value, it was just 0. And it turns out the easiest way to do that was to use intercept form. All right, but just be aware there's a lot of different ways to do these problems. So on to number 14. Now again, intercept form is the easiest form, so I'm just going to factor out a negative 3, actually a negative 3x. I'm factoring out the greatest common factor. And to see why that works, we can just multiply back. Negative 3x times x is negative 3x squared, and negative 3x times 2 is, actually that should be a negative. Negative 3x times negative 2 is positive 6x. All right, so now I'm going to change the x to x minus 0. And you can see, obviously, it's in intercept form at this point. So a is negative 3, and m is 0, and n is 2. Remember, the signs change. That's negative 2, so we have to change it to positive 2. And 0 doesn't really matter what the sign is. So now, again, you don't have to use this formula, but I just want you to know how it's used. We can use that formula to find the x value of the vertex. 2 over 2, and the x value of the vertex is 1. And now we find the y value of the vertex, and it's easier to use this equation here. So we just plug in 1. And just to be clear where that came from, it came from there. So now the y value of the vertex is, we have to do the parentheses first. 1 minus 2 is negative 1. And then we get positive 3. Okay, so 1, 3 will be about there, and this parabola is going down. And let's see here. Now we can use the intercepts, which are 0 and 2. And we just connect the dots. And so there you go. So that was, again, just a variation of the problems that we did in the previous class. You know, I just remembered that I forgot to do the first step there. Let me just move this down real quick. First step is to write the intercepts 0, 0, and 2, 0. And this would actually be the second step. Sorry about that. Okay, so I'm going to leave 14 in the window. So you want to factor out the greatest common factor here. And that's obviously going to be x. And change it to intercept form. And then just graph it like you're used to graphing using the intercept form. So try number 15. And when you come back, we'll do it together. All right, we're back. So we're going to factor out the greatest common factor. And how do I know x is the greatest common factor? Well, because if you distribute back, you get x squared minus 6x. So now I'm going to change x to x minus 0 because that's perfectly legal. And then you have intercept form, which means a is equal to 1, m is equal to 0, and n is equal to 6. And the first step is just to find the intercepts, which we know just by looking at the equation. And then we just have to find the vertex, and we can use that formula. And m is 0, n is 6, divide by 2. And we get 3 for the x value of the vertex. Then to find the y value of the vertex, as usual, we just use one of those equations up there, and that's going to be the easiest one. And then we have 3 times 3 minus 6. And so we get 3 times negative 3, which is negative 9. So 3, negative 9. I'm going to plot that. 1, 2, 3, and then we go down 5, and then 6, 7, 8, 9. It's going to be about there. And this parabola opens upward. So now I can use the intercepts, which we know are 0 and 6. So that's 6, 0, and 0, 0. And we just connect the dots. So if you got a parabola that looks something like that, good job. Again, it doesn't have to be perfect. Okay, so if you got that answer, good job. On to the next problem. We're going to try another one of those. Now this problem, you're going to have to deal with some fractions. So just be aware of that. That's why I said you could use your calculator. You don't really need to use your calculator, but if you want to, you can. So go ahead and try number 16. You're going to have to factor out the greatest common factor. And you can take a screenshot of number 14. That's going to help quite a bit if you want. So try number 16, and when you come back, we'll do it together. All right, we're back. So I'm going to factor out negative 4x because that's the greatest common factor. And then I'm going to change x to x minus 0 because that's completely legal. Again, I just took this x and turned it into an x minus 0. And now we see it's in intercept form. Remember, the signs have to change. Step 1 is to find the x-intercepts, but we kind of already did that. So that's an easy thing. That's the benefit of intercept form, is we can see what the intercepts are just by looking at it. So now we go to step 2 to find the x value of the vertex, which is just m plus n over 2. And we have 0 plus negative 3 over 2. And this is the problem. We end up with a fraction. And you can write that as a decimal or a fraction, whichever way is easier. So now we have to do some math, unfortunately. It'd probably be best to use that form there. So we have negative 4 times negative 3/2 times negative 3/2 plus 3. So I'm just plugging that in from here. Okay, so the y value of the vertex is negative 4 times negative 3/2. You can do multiple steps at once. So now we have to add these together. Now 3 is the same thing as 6 over 2. Again, if you're rusty on that, just go back to my arithmetic course. So 6 over 2 plus negative 3 over 2 is 3 over 2. And just multiplying those, negative 3/2 times positive 3/2 is negative 9/4. You don't have to show all these steps, but now when you're multiplying these, the 4's just cancel out, and you're left with negative 9. Actually, positive 9. Sorry about that. Positive. Again, if you're rusty on the arithmetic, I'm doing shortcuts here. You see, I'm doing the cross canceling method, and you need to get to the point where you can start using shortcuts. Now, if you don't want to use shortcuts, you don't have to. But I'm not going to show all the arithmetic because we just don't have time. These are all shortcuts that you're expected to know by the time you get to more advanced math. So now the y value of the vertex is 9, so we have negative 3/2 and 9. So negative 3/2 is going to be about there because that's 1.5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is going down. And we already have the x-intercepts. That's 0 and negative 3. And we can connect the dots. And there you go. All right, so if you got that answer, good job. So on to number 17. Now this problem is going to be a lot easier because we already have intercept form. It just doesn't look like intercept form because it's just an x rather than an x minus 0. So I'm just going to change that x to x minus 0. And now you can see clearly that it's intercept form. A is equal to 1, m is equal to 0, and n is equal to negative 4. And so step 1 is to find the intercepts, and we can just see those intercepts immediately. And now we find the x value of the vertex. You don't have to use this m plus n over 2 formula. You can just find the midpoint between 0 and negative 4, which is obviously negative 2. But I just want you to know how to use that formula because sometimes it is beneficial. And we get negative 2. Then we need to find the y value of the vertex. We can probably just use that original formula up there, whichever is easier. So we have negative 2 times negative 2 plus 4. Again, I took that negative 2 and plugged it in there. So now we have negative 2 times 2, which is negative 4. So our vertex is negative 2 and negative 4. That's about there, and this parabola goes up. And we can label the intercepts, which is 0 and negative 4, and connect the dots. So that was a pretty easy example there. And you're thinking, why did we do that example? Well, again, it's just something that you may see. If you're not used to seeing something like that, you're not going to know how to graph it. Even though it's not hard to graph, you may not recognize it. So that's the whole point of this class, is to get you to recognize the different forms. So now I want you to try a problem like that. You can take a screenshot of the previous problem we did and go ahead and try number 18. And again, the first step is you're just going to replace x with x minus 0. And then you're going to see that it's in intercept form. So try number 18, and when you come back, we'll do it together. All right, we're back. So replacing x with x minus 0, we see that it's now in intercept form, and we can see all the constants. We don't really need a, but I'm just writing it just to let you know what the constants are. Whoops, that should be positive 6. Step 1 is to find the intercepts, which we can see just by looking at the equation. That's the beauty of intercept form. And now we want to find the x value of the vertex using that same old formula. So we have 0 plus 6 over 2, which is equal to 3. And the y value of the vertex, we can use this formula, this equation up here. Then we have 2 times 3 times 3 minus 6. And 2 times 3 is 6, and 3 minus 6 is negative 3, so we get negative 18. Again, I'm skipping forward a little bit there because if we had to show every single arithmetic algorithm, then this would just take too long. So 3, negative 18 is the vertex coordinates. 1, 2, 3, 1 all the way down to 10, and then 11, 12, 13, 14, 15, 16, 17, 18. So that's the vertex, 3, negative 18. And of course we can use the intercepts, which are 6 and 0. So 6 and 0, and we just connect the dots. I do this one first. And there you go. So if your parabola looks something like that, good job. Again, we're just exploring different forms of the quadratic expressions. Okay, so now we have yet another form, and now b is equal to 0, but c is not equal to 0, and a is not equal to 0. So you can interpret this in standard form as 3x squared plus 0x minus 2, because there's no b value. B is just 0. But it's actually easier to interpret it as a vertex form. Intercept form we cannot use in this case. We could convert to intercept form, but that would not be easy. So I'm going to write x minus 0 instead of x, and now you can see we're in vertex form. H is equal to 0 and k is equal to negative 2. So that's how we can interpret this. So step 1 is to find the vertex, and we already have the vertex. It's just 0, negative 2. Step 2 is to find a point around that vertex, and I'm going to use x equals 1. So if x equals 1, then y is equal to 3 times 1 squared minus 2. And just to be clear, I got that 1 from there. So doing the math on that, I'm not going to show all the steps, but y is equal to 1. Again, that's just basic order of operations. You should know that by now. You can go back to my arithmetic course under order of operations and review that if you need to. So now the vertex is 0, negative 2. That's about here. And we have another point 1, 1, which is here. Use symmetry and connect the dots. Now again, you can have a more accurate graph. That looks too much like a V, actually. You can have a more accurate graph by plotting more points, but I'm not going to require you to do that because that would just get too long and tedious. Okay, so as you can see, we could easily change this to vertex form. And so I want you to try one of those types of problems, get a screenshot of this, and try number 20. Easiest way to do it is to change it to vertex form. It's actually already in vertex form. We just can't see that it's in vertex form. So change x to x minus 0, And you can immediately see the vertex. So go ahead and try number 20. And when you come back, we'll do it together. All right, we're back. So I'm going to rewrite that as negative 2 x minus 0 squared plus 1. And now we can see it's in vertex form. A is equal to negative 2. H is equal to 0. And K is equal to 1. Remember, you never change the sign of this value. If this were an actual number, you'd have to change the sign. But I mean, if it were a number other than 0, you'd have to change the sign. But this number, you don't change the sign. So now step 1 is to find the vertex, and we already know the vertex is 0, 1. Then we just need to find another point, and we can probably choose x is equal to 1, and then y is equal to negative 2 times 1 squared plus 1, and doing the math on that, we get negative 1. So 0, 1 would be here, and 1, negative 1 would be about here. We can use symmetry, and we just connect the dots. So if you got that graph, good job. Again, these are just variations of the quadratic expression. So now we have another variation. So, we could actually write this in intercept form, and to do that, we could just factor like so. But I want to put this in vertex form. And, it actually already is in vertex form, but we just need to add a 0 there. So now we can see what the vertex is. It's just a negative 3, 0. Because we see that A is 2, H is equal to negative 3. Notice I changed the sign. And K is equal to 0. So now step 1 is to find the vertex, but we already see the vertex is negative 3, 0. Again, I should tell you there's many different ways to do these problems. So it's kind of overwhelming to show you every single method. So I'm just showing you the easiest methods. Okay, so now we're going to use x is equal to negative 2 to find another point there, and I'm going to use the original equation to find the corresponding y value. So again, we took the negative 2, plugged it in there, and doing all the math on that, we end up with 2. So let's plot those points. We have 1, 2, 3, 0, and negative 2, positive 2. And we can use symmetry, and negative 4, positive 2, and we just connect the dots. And again, try not to make your parabola too pointed, like my parabolas have been way too pointed. It's not supposed to look like a V, it's supposed to look rounded like that. Okay, so get a screenshot, because you're going to try a problem like that. I want you to try number 22. And when you come back, we'll do it together. All right, we're back. So as you can see, this is pretty much already in vertex form. If we add a 0, you can see the y value of the vertex. So A is equal to 1. H is equal to 5. Remember, you have to change the sign. And K is equal to 0. So step 1 is to find the vertex, which we already know is 5, 0. And step 2 is to just find another point we can use. So I'm going to use, I'm going to try x equals 3. You may have used a different x value. That's fine. So if x is 3, then we have 3 minus 5 squared. And that would be negative 2 squared, which gives us 4. So the vertex is 5, 0. Which is there. And the other point we use is 3, 4. So 1, 2, 3, 1, 2, 3, 4. And then we can use symmetry. The other point would be there. So 3, 4, 5, 0. And this point would be 7, 4. And that point is kind of in the way, so I'm going to have to move that over. I guess I'll try to write it down here. So if you got that parabola, good job. again, sorry my parabolas are looking like V's. They're not supposed to look like V's. Okay, so now we're going to do some problems with decimals. So we have standard form here. A is -1, B is 5, and C is now a decimal. Sometimes you're going to see decimals with these types of problems. You can see decimals pretty much anywhere. And step 1, as usual, is to find the x value of the vertex. Because this is standard form, we're going to use this same formula. So B is 5 and A is -1. And simplifying, that's a double negative, so we get a positive 5 over 2. And for graphing purposes, we can change that to 2 1/2. But remember, when you're calculating, you want to keep it as an improper fraction. It's just easier to deal with the numbers. So I'm going to now find the y value of the vertex. And I'm going to plug in. And let me get a little more room here. Okay, so we plugged in 5/2, and let's just simplify that. So 5/2 squared is 25 over 4, and we get 25 over 2 plus 0.7. Now we got to get a common denominator, so I'm going to multiply both sides of this fraction by 2. And we get 50 over 4 plus 0.7. Add those together and we get 25 over 4 plus 0.7. Now what do we do at this point? Well, we can change both of these to decimals, or we can change both of them to fractions. And you can do any way you want, but I think I'm going to change this to a decimal. So 4 goes into 25 6 times with a remainder of 1. And 1/4, you may recognize that, or you may know what the decimal form of that is. It's just 0.25. And you know, if you want to review how to change a fraction to a decimal, it's just take the numerator, divide by the denominator, add a 0, and just do the long division algorithm. 4 goes into 10 2 times. 4 times 2 is 8. 10 minus 8 is 2, so on and so forth. Add a 0. Goes in 5 times, bring up the decimal, so on and so forth. Again, that's just basic arithmetic. We don't really have time to go over that much now. So then we have 6.25 plus 0.7, and you can just consider this to be 0.70. You know, you can just add a 0. That might help you to contemplate what's going on here. So 70 plus 25 is 95, so we have 6.95. Again, this is just basic arithmetic. So now we have the vertex. It's 2 1/2 and 6.95. So 2 and 1/2 and 6, 1, 2, 3, 4, 5, 6, and 95 is right up there. All right, so now we're going to find, let's see here, I think we can maybe plug in 0 for x. So step 2, if x is 0, then y is obviously going to be equal to 0.7. You know, because again, this is always the y-intercept when standard form. So 0 and 0.7, that's going to be about here. 0 and 0.7. And it's going to be hard to use symmetry, so I'm just going to plug in 4 for x for the next point. So if x equals 4, y is equal to negative 4 squared, negative 16 plus 20 plus 0.7. Negative 16 plus 20 is 4, and then we have 4.7. So 4 and 4.7. 1, 2, 3, 4.7, that's about there. And now we just connect the dots. So again, if you see decimals in some of these problems, you need to be able to work with those decimals without being intimidated by them. I know it's a pain to have to work with decimals, but you've got no choice. Okay, so on to the next problem. Now we have a fraction in intercept form, but the fraction is actually, it's going to be one of the constants, one of the intercepts actually. So a equals 1 and m equals negative 1/2. Remember, you change the signs in intercept form. And so step 1, we can actually find the intercepts. We have negative 1/2, 0, and we have negative 3, 0. So we found the x-intercepts. Step 2 is to find the x value of the vertex, which, again, using this equation from those information boxes. But now we're going to have a fraction, and it's going to be harder to deal with this because of that fraction. So now we have to add negative 1/2 and negative 3. So negative 3 is the same thing as negative 6/2. Negative 6/2 plus negative 1/2 is negative 7/2. And there's a lot of different ways you could do it, but again, changing negative 3 to negative 6/2, that's just basic arithmetic. And remember, this means division, so now we have negative 7/2 divided by 2. But remember, whenever you're dividing anything relating to fractions, you just keep the dividend and you change to multiplication and flip the divisor and multiply straight across. 7 times 1 is 7, and 2 times 2 is 4. So the x value of the vertex is negative 7/4, and now I want to find the y value of the vertex. And we can just plug it into that. So negative 7/4 plus 1/2 sorry about that, the computer's lagging a little bit. Negative 7/4 plus 3. And we just have to calculate what that would be. So we can change this, multiply both sides by 2, and we get 2/4 plus negative 7/4 is negative 5/4. And we can change this to 12/4. 12/4 plus negative 7/4 is 5/4. And so multiplying those, we get negative 25/16, and we can change that to a mixed number so it's easier to graph. And we get negative 1 and 9/16. Okay, so negative 7/4 and negative 1 and 9/16, and we can change this to a mixed number if that makes it easier to graph. So negative 1 and 3/4 and negative 1 and 9/16. So negative 1 and 3/4 would be about there, and 1, 2, 3, 4, 5. Actually, I'm sorry, it should be just 1. 1 and 9/16. So that would be about there. All right. So this parabola is going to be going up, so we can label that point -1 3/4 and -1 9/16. And now we can use the intercepts, so -1/2 be about there, and -3 be about there. And label those points. And now all we have to do is just connect the dots. Alright, so again, just dealing with fractions in different places in those quadratic expressions. Alright, we have one more problem. Now we have a fraction and a decimal, you can see up there. We know that a is equal to -2, h is equal to -1/3. Remember, you change the sign on that one. And k, you do not change the sign, it just stays positive. Okay, so step 1 is to find the vertex, but we already have the vertex because this is in vertex form, so we can see what the vertex is just by looking at it. And step 2 is to find another point around the vertex. And, we have to choose wisely here. I'm going to choose 2/3. So that's just going to make the math easier. So y is equal to the following. And the reason I chose that point is because 2/3 plus 1/3 is just 1. That makes it really easy. And if we do the math on that, we end up with, well, I'll just go ahead and do it. And we have 0.5. Okay, so let's plot those points, -1/3 and 2.5. That's going to be about here. And 2/3 and 1/2. So 2/3 and 1/2, that would be about here. And what else can we do? I'm going to try to use, I think, -1 and 1/3. That's just going to make the math a lot easier. So this is step 3. If x equals -1 and 1/3, then if we plug that in, we have y is equal to -2, -1 and 1/3 plus 1/3 squared plus 2.5. And the reason I chose this -1 and 1/3 is because if we add these together, we just get -1. That's really easy to work with, that -1 there. -1 squared is equal to 1. And we have -2 plus 2.5. And finally, y is equal to 0.5. So it actually turned out that that was a problem to use symmetry. So -1 and 1/3 and 0.5 should be about there. And we can just connect the dots. Okay, so there you go. Those were some problems with decimals and fractions. So that was the class today. Let's take screenshots of all the work that we did to help you with your homework or to study for tests. Here's screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5 and number 6 and number 7 and number 8 and screenshot number 9 and number 10 number 11, number 12, and number 13. Now don't go before you get your homework. Let's take a look at the homework. Here's the homework. Here's screenshot number 1 of all the problems. And here's the answers for the problems. And the next page of the answers. And the last page. But before we go, I want to tell you that you need to show the work. See the red writing there? Show the work that helped you to graph each expression like we did in class. If you don't show your work, then that just proves that you didn't really do the problems, but you just copied the answers. You don't have to show all the calculations, but you do need to show some work to prove that you're actually graphing these expressions rather than just copying the answers that I wrote. Also, remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And remember, if you don't do the homework, you're going to learn nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.